Good afternoon, class. In today's video, what I wanted to do is to talk about optics. So in this case, in this video, what we're going to be doing is we're going to talk about lenses, and this one is going to be a little bit more on the conceptual side. I'll have more equations in the next video. So for this one, we're going to talk about the two types of lenses, convex and concave. So you may also have heard of them as convergent and divergent lenses. So I'll go over them and try to make sure you understand the differences between the two. So a concave lens, or is also known as a diverging lens. That's why I drew it kind of like this, because it's concave versus convex would be like this, and of course that's where you can have a little bit of a misconception about it, because a convex lens is also known as a converging lens. So just to keep that clear, make sure that everyone understands there's a difference. Convex bends outward, concave bends inward. And now, of course, these lenses will be viewed as much thinner when we do the actual math portion of this. But for this video, I did want to make sure that these lenses were a little bit thicker, because what I wanted to do was to show you why there is all of these, why diverging lenses bend light the way they do, and why converging lenses bend light the way they do. Usually when I do this, or usually when you see this done on many other videos, you would just see the light would enter and it would bend, and we would just call that good. But what I wanted to do was show you actually why, using the geometry of the lens plus drawing a little bit of the normal, why you get certain images, why you get certain like focal lengths, and how all the light bends with respect to the normal, and using all of the things that we learned from light, especially about indices of refraction. So let's start. I'm going to start on the left, because at some point I'm probably going to be moving more in frames. So if I cover that up, at least you have seen this part. So we'll talk about a concave lens first. If you notice, the black lines right over here these black dotted lines are representing the normal. So I've got three main beams of light. This is not to say that there are three different images of light. That's just saying that there are three different parts of the actual light beam that's coming into the lens itself. Okay, so you could even think of it as parts of the image. So maybe if I had an image of something, let's say a tree over here, where would the image, if the object was a tree, and let's say I put it over here, where would the image of that tree be? Would it be over here? Would it be over here? That's what we have to figure out. But first, we're going to talk about using the index of refraction. We're going to see how the light actually bends. Don't forget, this is coming from air, so of course the bending of light would be a little bit different if this was coming from, let's say if you put these lenses in water, let's say. But we're going to go with air, so we're going from air into glass, and so what will happen is this has a higher index of refraction. So when this top, see, and if you notice that in this middle line right here, it goes straight through, no bending, no nothing. And the reason for that is because the normal actually points exactly along the line of the light beam itself. So even though there may be a slowdown of the speed of light within the glass, there is no bending of it, because it's coming in exactly at 0 degrees to the normal, with respect to the normal. So let's talk about this one, where the light beam is not coming in 0 degrees to the normal. There is actually an angle of incidence. So what happened is, like we learned from in the video about refraction, if it's going from a lower index of refraction to a higher index of refraction, the light will bend towards the normal. So that's why you can see this over here. There's this angle that's made over here, and this angle that's made over here after it went through the normal. What happened is that the light became a little bit more, it bent towards that normal. Now, the whole reason that this light starts to diverge out this way is because of the geometry of this lens. Because it is concave, bending towards the normal, which points inward like this, means that it's going to bend up. Okay, so just want to make sure that that's a little bit, we kind of get that image. And of course, when it hits the other end of the glass, it'll bend away from the normal because it's going from a higher index of refraction to a lower index of refraction. So that's how that looks. And of course, the exact same physics is occurring at the bottom of the lens. So that's why I'm not going to deal with that in this case, nor am I going to deal with the bottom of the lens in the convex lens either. So that's what will happen. Now, if you'll notice, the light that has come through this diverging lens or this concave lens never actually focuses over here. It actually it looks like it's focusing all the way back here. This will come up. This will be important when we start talking about images, but we'll get to that in a little bit. I thought I'd just point that out as something that you should be taking note of. So let's go on to a convex lens. In this case, the lenses bend outward instead of bending inward. The same physics will actually apply. You're going from a lower index of refraction to a higher index of refraction. The only reason that this looks a little bit different over here is because the normal is not going straight up like this. It's going more off at an angle. And so because that angle is pointing outward like this, when it bends towards the normal, it instead of it bending up like it did in the concave lens, it starts to bend down in this convex lens. And that's why the light will go hit the top of the converging lens and bend down towards the center line of this of the lens. And of course, the middle line, the middle beam of light goes right through because the normal and the surface of the lens are exactly parallel. They're the exact same angle with each other. So there's only a slowdown. There's no bending of the light that's going through that portion. And of course, like I said, this bottom portion, same physics as the one up here. So I'm not going to really go into all of that because it's more of the same. So now that we've gotten all of that, we need to talk about the types of images that can be gained from these lenses. What do you see after looking through some of these lenses? So there are two types of lenses. One is real and the other is virtual. And so a real image, let's talk about first the differences. A real image can be projected onto a screen. So that means if I were to send the beam of light through this, and let's say I had a screen over here, you would actually see something. Whereas a virtual image cannot be projected onto a screen. So while I can use a diverging lens or a concave lens to magnify something and see an image of it, if I were to put a screen over here, I would get nothing. There would be no image that I could get through and project onto this part. So it's kind of like a movie screen. Think of it like a movie projector or a slideshow projector. Those things you can think of as an example of a converging lens because they project real images onto screens for you to see. So anytime, like if you've seen the latest movie in the theaters, there you go. That would be an example of that, of converging lenses. Now, one of the things that I'll get into this more in the second video of this series, where I talk about why or how they become this way. But one of the key ideas is that a real image will generally be a little bit smaller, but it will also be upside down. It'll be real, projected on a screen, but it'll also be upside down. Whereas a virtual image will be magnified and upright, but you cannot project it on a screen. So I'll talk about why that is, or like how you can actually deal with those kind of things. Maybe since I'll have more space in the next video, I'll actually draw some example images of what this looks like. But that's where we're headed. This is just to give you kind of the basic vocabulary understandings of how to deal with convex and concave lenses. And after this, I'll do an example. I'll actually have actual convex and concave lenses to show you to see what it looks like. But what just to give it as a demo, then in the next video after that, I'll do some actual math and equations with it. So that concludes this introduction to lenses. Good luck in your studies. May the force be with you.